Hey televisions, back with me again, Aji Gautama Putrada. I am your lecturer for Parallel and Distributed Systems. This is our 8th meeting about Parallel Systems Introduction, and we have reached the 5th video. In the 5th video, we will discuss about Flynn's Taxonomy. Let's start the video. So, if in the last video we are discussing about the history of parallel systems, in this video we will discuss how do we do parallel systems. The opposite of parallel is serial. So it is just like this. In serial processing, several tasks are done by one CPU. And in parallel system, several tasks are done by several CPUs. So that's a parallel system, and in the next slide I'll show an example. So here's an example. So for example, we have to do things adding and subbing, and it turns out that we have to add two things here, 1 and 2 and 3 and 4, and we have to sub two things also, 1 and 2 and 3 and 4. So totally we have 4 things to do, and if we only have one processor, it means that one processor does 4 things, which is adding 1 and 2, adding 3 and 4, and then subbing 1 with 2 and subbing 3 with 4. But if we have more than one processor, we can divide those tasks into those processors, and we have actually 3 different scenarios. And so here, if we have 2 CPUs, for example CPU 1 and CPU 2. So CPU 1 can do half the job and CPU 2 can do the rest. And for example, if CPU 1 is doing add 1 and 2 at the same time, CPU 2 can do add 3 and 4. And if CPU 1 does sub 1 and 2, CPU 2 can do sub 3 and 4. So it's faster. And in the second scenario, we can imagine that one CPU is designated to do adding. So there is an add CPU, and the second CPU is a sub CPU. So one CPU specializes in adding, and one CPU specializes in sub. So if there are 2 tasks, the add CPU does add 1 and 2, and does add 3 and 4. And the sub CPU does sub 1 and 2 and sub 3 and 4. And for example, we have 4 CPUs, and so there are 2 add CPUs and 2 sub CPUs. So it's even more faster. So add CPU 1 and add CPU 2, and we have sub CPU 1 and sub CPU 2. And so this will finish in one execution time, each of them with different tasks, 1 and 2, 3 and 4, and here 1 and 2, and 3 and 4. So each of these scenarios have a name. So there are 4 ways to complete the previous task, and these different ways has different names. So the first way, where one CPU does 4 tasks, is called SISD, and SISD is actually serial, and the 3 others are parallel. So if there are 2 CPUs and those 2 CPUs are doing different tasks, that is called SIMD. And in the first scenario, where there is one designated adding CPU and one designated subbing CPU, that is called MISD. So multiple instructions with the same data. And if we have 2 adding CPUs and 2 subbing CPUs, and all of them are doing different things, that is called MIMD. And this is what we call Flynn's taxonomy. So there are 4 ways of solving several tasks at the same time. So in this video, we have successfully discussed about Flynn taxonomy. That is all, and I'll meet you in the next video. Thank you for your attention.